All right, folks, let's jump into some problems having to do with frequency and period in simple harmonic motion. This first one is really just because I wanted you to have to do something with frequency. Write out expressions for the frequency of a mass spring oscillator and a pendulum. So I recommend that you do this yourself. We know that frequency is 1 over period. So I would challenge you to pause the video, write out the frequency expressions, and then check your answers. Okay, here I go. The frequency of a spring, it is the reciprocal of the period of a spring equation. So 2 pi becomes 1 over 2 pi, and then the square root of m over k becomes the reciprocal of the square root of m over k, which is the square root of k over m. And for the reasons why m and k affect period, they affect frequency the opposite way because they are reciprocals. The frequency of a pendulum is going to be 1 over 2 pi times the square root of g over the length of a pendulum. Okay, moving on. This next one. A spring and a pendulum both oscillate a mass that has the same mass, and the ratio of their periods is 1 to 1. So K for the spring, L for the pendulum, and mass for both, and they oscillate with the same period. Find the new ratio if the masses are replaced with an object of mass 4m. So part of this problem is recognizing that the period of the pendulum won't change because the mass of the mass that's at the end of the pendulum does not affect the period of the pendulum. However, the period of the spring will change, 2 pi root m over k. So there will now be a new period of this pendulum that's going to be based on a mass of 4m. Now, if I multiply the mass by 4, that effect gets square rooted, and so my new period is going to be double my old period, right? Because 4 times the mass gives us double the period. So the new ratio, it used to be 1 to 1, but now the period of the spring is double, and now it's 2 to 1. All right, so you should expect questions like that have you compare a pendulum and a spring and change things that affect the period of one but not the other. Another classic one is to change the length of the spring and the pendulum and then find the new ratio or find what changes. That's a good one. All right, last one. Spring with a force constant K oscillates mass m with a period tau. In terms of K, what's the new force constant that would oscillate a mass of 2m with a period of tau over 2? So algebra with this equation is a little trickier than average, but you've been through a lot here in physics, and so I'm going to probably ask you to do this again. So why don't you pause the video and try and solve this for K, because this question is about the force constant. We want to know the expression for K based on this equation. So pause your videos. And here we go. So if I wanted to solve for K, one thing I could do is I could square everything in this equation. I would get tau squared equals 4 pi squared times m over k. And I need to do that because I have to solve for k. I don't want to solve for the square root of k. I also have k in the denominator, so I'm going to multiply both sides by k, and I get k times tau squared equals 4 pi squared m. I often find it useful to get everything on the same line so that then it's just what do I divide, and that's it. So my expression for k is now going to be 4 pi squared m over tau. All right, so now I can answer the question. If I want to consider this new value of k, that is going to be based on double the mass and half the period. But keep in mind that because of the way I solve this, the period gets squared. The new force constant is going to be 2 over 1/2 squared times the old force constant. again, because doubling the mass and halving the period are the only changes I made. And so that's the only math I need to consider. This 4 pi squared was constant, so I ignore it. So my new force constant, 2 over 1 half squared. So 1 half squared is 1/4. 2 over 1/4 is equal to 8. My new force constant has 8 times the value of my old one. So that's hopefully enough to get you started on some practice.